We know that orbital wave function or psi doesn't have any physical meaning. I already discussed in a previous class. And here I'll show in this graph that 1s and 2s orbitals. 1s means when the principal quantum number 1 and azimuthal quantum number 0, and for the 2s orbitals, principal quantum number n is equal to 2 and azimuthal quantum number L is equal to 0. In this graph, you can see the figure number A. This is related to the psi versus the r. R means the distance of atomic orbitals from the nucleus. And for the figure number B, this is the psi square versus r. The distance r is always in nanometer. I'll discuss this in details now. So, psi versus r, it is not that much important because the psi doesn't have any physical meaning. So, we'll discuss on the psi square value. Psi square means is the probability density. And for the 1s, if you find this graph, then psi square value, that is probability density of electrons in an orbital, suddenly drop to 0 with increase of its distance r from nucleus. And with the increase of r, this psi square value, that is probability density, will remain 0. This is the case for the 1s orbital. But for 2s orbitals, that means 2s orbitals, this is that graph, psi square versus r. Then psi square value in this case suddenly drop with increasing of the r value, and it drops, psi square value drops to 0. And again, it increases slightly with the increasing of r value, and again it decreases psi square value to 0, and it will continue. This is the case for the 2s. So, where with the increase of the r value, this psi square value, here it is the 0. This point we call node. And this is the 2s orbitals. 2s orbitals means principal quantum number is 2. And in that case, we find the node 1. That means 2 minus 1 is equal to 1. Here it is clearly mentioned that for the ns orbital, the orbital has n minus 1 nodes. And for 2s, how many nodes it will be? 2 minus 1, 1 node. So we found 1 nodes. So similarly, for the 3s orbitals, how many nodes will get? Yes, 3 minus 1 is equal to 2, and so on. And to see the probability density variation, if you visualize by this diagram, then you see all is the charge density. So this is case for 1s, and right side this is case for the 2s. And if you put the boundary, then it is the boundary surface diagram, and found in the figure number B, the boundary surface diagram for 1s and for 2s. I hope that you understand the shape of atomic orbitals, its graph, psi square versus r, clearly.